YG Bala, Assistant Professor, Department of Mechanical Engineering at Motilal Nehru NIT Allahabad. Her area of research includes particulate processing, material testing, and characterization manufacturing technology. She has published 11 national and international journals and 7 conference papers, out of which one of her papers has won second prize award at National Engineering College, Kolipati. She is currently guiding 2 PhD scholars. With this brief intro, now I request Dr. YG Bala to begin her lecture. Over to you, ma'am.
Thank you. I thank this NIT Silachar, Mr. Dr. Dinesh Kumar, the head and the director, for giving me the opportunity to deliver their lecture in CNC tooling, 5-axis tooling. So I will share my screen. So are you getting the screen?
Yes, ma'am.
Today, my topic is on tooling system in 5-axis CNC machine. We know all that so many advantages over this CNC machine, CNC technology. Why we are using this tooling. Everything we have that. So in that, I am going to specific what type of different toolings or cutting tools, both work holding devices and tool holding devices, that will enhance the system to improve the productivity and all. Okay. So let me brief the introduction of this 5-axis CNC. So already it has an high efficiency and high quality of processing, and as compared to our conventional CNCs, where it have this 2-axis, 3-axis turning machines or milling machine. In addition, it will have some 2-axis. Okay, that's why we are considering here the 5-axis is more identified to do complex shapes. So it, in addition, what type of attachment it has means it has additional two rotary axes. Apart from this XYZ linear axis, it has the additional 2-axis. So that two axis, either it may be of rotary axis tilting the tool with respect to the part, or either tool that is tilting to the part that which we want to machining. Okay, so that is the basic idea of this 5-axis CNC machine. So here either workpiece is fed in that axis XYZ, or either in A, B, or C. And ultimate aim of our CNC, this 5-axis should be, it has to reach all the 5 sides of the component with a single holding that part. Okay, that is if you take the prismatic component, apart from the resting of the side which it has been molded, so the all the 5 sides, it has to either the tool or the part has to be reach each other without modifying or without changing or without removing the part from that axis. That's why it is highly helpful in getting this complex contour shapes by simultaneous action of this 5-axis, and also that the degree of part towards the tool or either the cutting tool towards the part. Okay, it should not reach to exact to a 90 degrees. So when it is trying to reach all the 5 sides, it has to be positioned apart from that 90 degrees also. So that also we have to take consideration of this 5-axis CNC. Another thing is, all this fancy, the higher end it is for high speed machinings. Okay, and the tools which they are concerned with that high speed, the longer tools will try to vibrate or try to deflect based on that higher speeds or feeds and all that. So that we have to satisfy that. So better to use this shorter tools for the faster speed. It will emit the lower vibration so that we can able to achieve our effective machining parts in terms of finishing, as well as in the term of production time also we can achieve by this tooling in the 5-axis CNC machines. And when you are going for multi-axis also, the approach, it will be remain same for the setting for clamping or whatever the other thing. So it is, once it is clamped means we have to able to reach the maximum portion of the part. so that the machining time is also get optimized and we can able to get this complex part. Similarly, the attachments what we have to use, like when you are going for milling, drilling, or some drilling related operations, so we need not to reclamp the part for the secondary operations or the secondary part changing or going to the another machine, so that it can be obtained in this 5-axis machine. And we can able to eliminate the errors. Okay, and the need here, it is where the calibration it is needed is one for integrating it with the clamping positions. Okay. And next, what things we have to consider when we are going for the tooling in the 5-axis CNC machine is, we all know that we have even in a conventional CNC machines, either in the 2-axis or 3-axis, either turning centers, milling centers, or machining centers, the tool plays a vital role. Okay, because the better the tool, you will get a better machining of the process and you will get a better machining time. Okay, and here for the 5-axis machine also, we have to upgrade with the tooling assorts and what are the grades of inserts which we are coming, so that the better tool life we can get it, and we will get that what type of latest material that will be economic and efficiency. Okay, and also tool inventories, all these NC machines, they will be combined with the tool holding system or automatic tool changer, that provisions will be there. So in tool holding, generally we may go for 40 to 60 or even 120 toolings will be set up in the ATZ machines. Okay, so that inventory also we have to take care in the 5-axis machines, so that the repetition or different types of settings should be avoided. Okay, even a single setup of ATC can help you to calling the different number of tools. So that type of some standard methods and standard quicker changes that we have to make in this 5-axis CNC machines. And also we have to pay the clearance and the elimination of the interference between the working fixtures, the machine table, the spindle housing, and the cutting tools. Okay, because why the interference is very, very important is we are not going to change the setup. Once you have fixed, our aim is to reach at least the 5 parts of the work part to be the either the tool to be reached. Okay, so that interference is very, very important in terms of this cutter radius compensation or tool nose compensation. Everything we have to take in the consideration while thinking about the tooling for the CNC machine, because when setup is changing, when tool offset length or cutter radius when it is changing, so every time we have to stop the machine or the part, we have to calibrate the settings of the tools. Okay, because in ATC we will able to use the different types of tools, so at that time it will incur in the terms of lead times, which the unproductivity time, so that will increase, that we have to minimize, or we should at least we have to optimize that timing. So based on that, we have to consider that interference between the fixtures and the machine tools, and necessary clearance also to be provided for the workpiece. Otherwise the collisions or the clamping fixtures locating, that it will spoil the working environment of the automations or CNC machine. That also we have to take into consideration. Another thing, the positioning. So here we cannot able to exactly position the tool or the workpiece exact to the 90 degrees. So there will be other degrees that only will promote the 4th and the 5th axis of your NC machine, this 5-axis CNC machines. So this can be accomplished by using this instead of going for a longer tools and more vibrations. So that can be reduced by using the proper cutting parameters and the shorter cutting length tools. Okay, by that we can able to get this improved finishing. Another thing is chip control. Okay, so this can be accomplished by this high pressure coolant. So which, because that is accumulation of the chip will also encounter a problem during the machining process, because there should be a proper chipping out of the machine. It will affect not only the part of the work part which we are machining. Apart from that, it will damage the machine also, machine component also, if unless it is not periodically maintained. So in that, there should be a periodic maintenance should be there, or maintenance before failure. That everything we have to take into a consideration. Okay, so it will improve your better life of the CNC machines. And next is the holding equipment for tool as well as the workpiece. So preferably wherever the machine tables, okay, as far as the work piece is concerned, the machine parent table will be there. In that, by holding a different fixtures, we can able to achieve this different axis of action of the tool with respect to the workpiece. We can achieve it, and this can be accomplished either different types of clamps or there, zero clamp, hydraulic clamp, or this different vices are there. So by that we can bring out this achievement of different contour profiles in this 5-axis CNCs, and also this tool holders and the cutting holders. To improve the productivity, we can go for this ATC with a different magazine, as well as for changeover of the workpiece we will go for this palette changes also. So by that we can able to achieve our cycle time, least cycle time, with the more productions we can able to achieve in this CNC 5-axis CNC machine. Then the important thing which specific in the compared to the other CNC machine is that either this swelling head, that is non-tilting table on a swelling head machine. So for having the very big component or any specific precision components, so that we can use this swelling head or turn ion tables. And also we can use multiple fixtures or vices like tombstones. So they are all can be used to accomplish this different profile contouring. And also both this rotary action as well as this linear action, either by table to be a rotary, spindle to be a stationary, or spindle to be a rotary and table to be a stationary. So by that we can able to achieve that different possibilities of the machining process. Here you can see that rotary table and rotary head for 5-axis CNC machine. See here, what are those 5 axes? Okay, either it may be a 4+1 axis or 3+2 axis. Okay, so generally head rotary axis and two axis that will be situated in the head structures. And this 3 linear axis, it is concerned with that our x, y, z movement, and the other second rotational. In the if we are going in terms of head, rotary head, if you are talking, that fork head will have that second additional rotation. Okay. And if you are going for the table or the rotary head axis, the revolving axis will be the head. Okay. And that will be that revolving axis will have the restricted range, wherein we don't have any scope for the founding the other configuration of the tables. If table and the table is the rotary axis, and two axes can be combined into a turn ion. So here the traveling of one revolving axis will have that limitation, while the other axis does not will have any limitation on that. So these type of arrangement we can use for preparing of molds and dies, and for running at the very higher speeds and stable cutting condition we can accomplish by this rotary head, either on the rotary head side or the rotary table axis. So different configuration it accomplished based on the machine specifications we can able to accomplish this. So here you can see this head which having this pivot head. This is a one type of configuration that it will have a double pivot spindle head. In this type, two rotating head coordinates control the direction of the tool axis. You can see here the A and C. But this is not be provided in our conventional 3-axis or 2-axis CNC machine. This is one type of this head type. Another is a pitching swing head type. See here again you can see that C and B plus direction of it. So here it is of the tool. Okay, but rotation axis is not perpendicular to the linear axis. You can see with respect to the table, it is not the perpendicular. It is deviate apart from it. It has to coordinate this tool head. And this is the rotary table, okay, where your tool head is, even it is a pivoting, you can able to get the other axis in the turn ion tables. Okay, so that is the 5-axis, two rotating coordinates directly control and the rotation of this space, that is C and A, you can see in the picture. And next is the pitching of the work table. Okay, so here again the two coordinate axes on the work table. the rotation of the axis here again, it is not perpendicular. You can see this B, that is a rotary of that B, and this C axis. Okay, so this is the another form of work table where we can achieve that specific degree of freedom. Another is a rotary table and the pivoting spindle head. So here again to coordinate that act in the different places. Yes, A it is acting in the tool head and the C it is acting in the work table. Okay, so by this we can able to accomplish this different contours for providing on the workpiece part. Okay, so by different positioning of this table and the tool only we are achieving this different complex profiles in this 5-axis CNC machine. How this additional 2 axes are accomplished by these different alignments. So apart from that, we can able to have a special attachments. We call this as an aggregate heads. Generally, it is used for this boring and sawing outputs. So here you can able to see a single, double, even the 4 output with the same head. There will be as well these 4 first figure. If you see, it is a single. Okay, and this one is the fourth one, second one, and the third. We can have this 2 head and this swelling at a different. This holding wise will be there. Okay, so by this different combinations of the heads, we can able to hire the high profile components we can manufacture. Okay. And here another type of single axis spindle head. Generally, it will be of pendulum types. This will provide this double tilt tables or multiple axis spindle heads with rotary action. It can be formed. It another combination is a single rotary tables. So that is will be a good choice for this 5-axis machining for small to medium size production for this concave and convex shape components, as well as for the prismatic long slender components also we can able to provide this configuration. And the B axis always enable the spindle to rotate around the tool tip, and by that is any angular errors can also be eliminated by this B axis. Okay, another 2-axis head is a spindle head, and generally it will be used in the gantry type machining centers or vertical machining centers. That C axis will be have an unlimited range of the motion, while A axis will be limited to this plus or within this 90 degrees. The A axis will be there, wherein the C axis you will may have this unlimited range, and you can able to have a different profiles. So these are based on that different tables and tool head. So here we can able to see the different types of rotary tables which we are using in present application. So here you can have this uh, high speed this is all driven by this cycloidal gear drives. Okay, so this one type of chuck arrangements, and this is a single table, and this is a double table holder, and this is a through hole vice tables, and this also a through hole tables. So based on that, by different fixtures we can able to enhance in this this part, this base plate parts, and we can achieve the different part of contouring mechanisms. And next, coming for this holding devices, work holding devices. So the great challenge in the 5-axis it is without changing the clamping, we have to either it is a bulk part or a smaller part. Without changing it, we have to reach the all the sides of the part. Okay, at least the 5 parts of the component it has to be reached. Okay, so that should be the basic challenge in our 5-axis CNC machine. So how this can be accomplished, we will see. So here the basic thing is the work holding should be provide this quick changeover of handling the work part material. Okay, so here on you can see a base plate where it will have some standard holes will be there where easily you can fit your accessories over it, and you can dismantle it. Okay, so that it can reach the multiple side of the machinings you can do it. And this is also another arrangement. So here this locating pins will be there. Okay, so without obstructing that top side or any other side, even one part you will be completing, when you are changing it, it should not uh, that is disturb the already machined component. Okay, so without that, the subsequent operation we have to do it. So these are the other arrangement. So apart from that, over that common base plate, what type of devices we are using in this five axis CNC setup? One is a zero clamp point, another is a centering vise, and centering vise with serrated jaws, double station vises, dovetail fixtures, dovetail with gripper teeth, multi-side work holding devices, and there will be some specially designed features which according to the manufacturer or the company they will do by themselves. Okay, DY methods, they will accomplish this holding devices. Based on the application they will utilize the fixtures. So this one is a zero clamping point. So this for this 5 axis. Okay, so just it will come with different pointers and locations. So we can able to place over this a table, a common configuration table will be there. Either this T slot plate or any angular plates or whatever the base plates, over that we can able to fix it. Of different configuration we can fix it. Okay, so this is one zero clamp plate. So here again you can see different zero clamps will be there. One over the other you can clamp it, and finally you can fix your workpiece, the vices. Within the vise you can fix it, and you can able to index the component, and you can able to do the configuration of the other 5 sides. So the first picture you can see, the bottom is the fixture of the plane where this top contouring, like a drilling dreaming process you can do it. And this is for turning related operations, where it is in the axis of the spindle, it is horizontal to the base. Okay, so for that these type of setups we can use it. Okay. And coming to the vise, different types of vise, we have this centering vise. So it is a simple jaws we have. So within that it will be self-centeringly, it will hold the workpiece. Okay, even with a very small work component to a medium size to a maximum size, it will be hold very griply. Okay, so generally the vise devices, they will be made up of this nickel chromium steels, based on the process of quenching and heat treated. Generally the vise are manufactured, and even this vise we have this plain vise, or we can have the vise with serrated jaws. Can the second picture, it has some profiles. Okay, it is for enhance the gripping of the part which has been to be machined. Okay, so that is the alignment should not change. That's why when compared to other automation, why the machining we are going for CNC is we should get an exact dimensional tolerance in the machining process. That's why when compared, so many different manufacturing process are there, but why we are going for the machining in this we have to achieve that exact dimensional of the part. Okay, so when our location is at a single time, even the deviation of 1 mm will lead to the deviation of the error of tolerance maximum. Error will be incurred, where it will encounter in the rejection of the product also. Okay, so to minimize that only, the gripping force, because during a machining lot of radial forces, thrust force will be acting. So every the component, either it is a fragile component or a high strength component, the vise should hold it firmly. Okay, so for that we are using this serrated jaws. In the serrated jaws, what they will do is, with the component which we want to do a machining, they will do that same serrated impression on that work part also. So it will exactly fix on that fixture. So we cannot, we don't need any mechanical stops or any thing to fix the position of the workpiece. Okay, so for that this serrated jaws will be highly helpful. And this is a double station for multiple parts. When you are going for a number of components, two components you are want to machining at the same time, or same part you want to manufacture. So for that we can go for this double station, and even multiple station is also available. So this is an example of this double station vise. And this is a dovetail vise. So the previous, it is a simple planar structure. So another popular fixture is a dovetail fixture. Here you can see that the top base, it will have this inclination of a dovetail. Okay, so it will be angled that the clamp will accept that workpiece. Okay, the workpiece should also be in that dovetail shape. Okay, so this is also to enhance the gripping power of the work part in the machine. Okay, so for that we are using it. And here this type of dovetail fixtures, we have this locating pins where the between that flat surface and the jaws. Okay, so the dovetail will act as a locator for the part in one direction, and the pin will act as a locator for the other part in the other side direction. And here we will use a simple this double pins to locate it on the fixtures. So here you can see how that serrated tip will be entangled with your workpiece. Okay, so here mild impression will be taking place in this simple serrated type, and in the dovetail you can see the dovetail of the workpiece also it has been made. Okay, so this for going for serrated, we should go the limited of hardness will be HRC 38 or less than that. We will go for this serrated type jaws. And dovetail, it will give a very positive clamping for very harder materials. You can go for this dovetail. Okay. And next, this is also a dovetail type workpiece. See here, you can see how this clampings are there. There is one adapter plate and the riser is there and vise, and then over that dovetail workpiece has been kept. The purpose of the adapter, it is clamping. This entire thing will be clamped in our either in our rotary tables or in the milling machine, whatever the table features we have, in that this adapter plate can be accommodated. And the function of the riser is to the height of the this one component in the vise range, how it can be able to accommodate with the vise. For that we will use this risers. And here again we have this locator slots will be there. For the material we have to look, we have to make the workpiece this dovetail locators we have to make in the workpiece so that it can fix in that vise also. Okay. And this also dovetail vise with the gripper teeth. So you can see the surface, it is not plain. So this dovetail, we have this gripper, it will enhance the gripping force only. So maximum up to 22 tons torque force will be there. So which is sufficient to withstand the machining forces. Okay. So here you can able to see that how the different over the table, how the component this vises were being fixed. So for this horizontal components and as well as this vertical components, you can able to see here. So this the table is the planar table, and here it is a rotary in the spindle direction. The rotary axis is different. Okay. And this is the other type of working holding devices that is multi-sided. Okay, so it does not mean that only one component we can hold. So when you are going for the mass production of the component from medium size, from low range to medium size, when you are going, then we can go for this multi-sided holding devices. So a similar concept, it will have this pinholes, so where you can hold the different jaws. So you can do the machining at a different positioning, you can do it. And see, these are specially accomplished where the necessity of the manufacturer or the product nature, we can go for this type of holding devices. And another, it is for milling vices. So this is a one milling vice which set for this high precision operation. So here generally it is used for holding blank this round and irregular shaped workpiece. For this we will hold it, and this is an extendable one. Okay, that extendable screw feature is there, so up to 7.87 inches we can able to hold, and it can able to withstand the force of 8900 lbs. We can able to withstand the cutting force. So here also there are other multiple fixtures. So this generally we will use in this vertical machine also. So this can also we can use in this 5-axis machine. This is a tombstone. So tombstone, it will come with some standard. Okay, even the distance between the locators, they all have the standard as per standards they will manufacture. Okay, so we can have this tombstone will come in triangular face, rectangular, hexagonal, octagonal face. So different phases will be there. So according to the phases, we can use as number of work pieces we can hold it. And this is a pyramid. The first one, it is a pyramid tops. So here also you can able to hold the multiple tools, and this is for the circular components, round bars. We can hold this type of fixtures. And next type of holding device, it is electropermanent magnetic chuck, where it is like it will have chess pattern types. Okay, so here the magnetic flow power will be in x and y axis. So because of the impulse of magnetizing and demagnetizing, we can able to load and unload our work components. So generally, it is perfectly we are using this for milling operations, and these are other type of standard setup for holding our workpiece part. So in a master plate will be there. So in the master plate, you can able to hold this different types of settings. You can able to see here the second picture also in rotary heads. So how different type of workpiece you can hold it. This can be for used for holding the workpiece as well as the tool also. This type of provisions we can use it. And next, coming for the cutting tools. So, in a general, what type of tools we are using it? Almost the material, if you see it, it will be equivalent to what we are using in this three-axis machines. With the extra this carbide tools, we will use some harder material because these concern with the high-speed machines. So we will go for the little harder material when compared to the other axis machines. So generally here the tool material should be of 40 to 60% stronger than your workpiece material, and it should have, as we are talking about this high speed machine, so it should be of highly that is it should withstand that temperature of that machining time duration, because it should have high thermal stability and it should have low coefficient of friction. So these are some properties regarding this cutting tools. And for 5-axis machine, we have to, with respect to the geometry of the shape, because mostly it is going for some specific profiles, contour profiles. It is not simple a planar profiles. So the geometry and the shape of the tool, it should be highly dependent for the making the profiles. Okay, so there are some unusual shapes you can do in that CNC machine, like hook surfaces, hollow machining, oblique holes. So they all depend upon both the cutting tool and the configuration of the table and the head when you are considering for this 5-axis machine. And here, so simple brief of this cutting tools, how we can classify the tools. One is based on the setting of the cutting tool, we have this preset tools, qualified and semi-qualified tools. And based on the construction, we have this solid brace tool and insert bit tools. And these are common materials which we are using in this CNC machine, the HSS tool, high carbon, cast alloy, cemented, carbide, ceramics, and even coated ceramics that plays a vital role in cutting this high-speed machines. And boron nitride tool, diamond, and Cylon. So these are different cutting tools we are using in the CNC machines. Okay, so there is not much variation when compared to your three-axis machine. So it has to that CNC it has to upgrade with the automatic. It has to adopt with that automatic tool changer also. Whatever the tool selection, the profile of the tool, it should be accommodated with the tool holders. Okay. And so the different commonly used tools in the NC machine, one is an end mill. So you can see the picture, all different types of end mills, different materials. One is a coated one, another is a normal cutting profiles. So these categorized by the height of the tool and as well as this cutter diameter and the edge end profiles. We can able to we can get the different profiles of the tools. Okay, so the multi-purpose tools here. This are the this mainly this end mills are used for cutting the lateral parts. Okay, and in the end mills also we have this different types of ends we have. One is a flat nose, ball nose, bull nose, and the chamber. So the application of this flat nose, it is for milling 2D contours and pockets. When you are going that type of profiles, we go for the end mills. This bull nose end mill, we have this radius corner will be there. So it can use for creating this fillet like structures. We can use this bull nose. And chamfer mills, it is for angular cross section, creating a chambers. So chamfers, we will use this type of end mills. And this ball nose, it is commonly used. So you can able to see this two types of ball nose end. One is along the tool itself, it has been this one. Another type is an insert type with multiple inserts. So this insert type nose ball mills also we can use. So this pointed uh, nose mill is also there. So it depends upon the type of profiles, the nature of the profile, what we are getting it. Okay. So it is all for this tilting type of tool axis. This allow this flute to grab the materials. Okay, and this you can able to provide this curved profiles and this part surfaces, this pulling ends and all. We can able to produce using this ball and nose mills. Another type of end mill is a V bit. So that the picture of this third one for having this V grooves, we will use this V bit tools. So generally it may have in the variation of 90 or 60 degrees. For these type of profiles, we using this V bits and multiple flutes. Okay, so either it is what type of end it may be. So based on the flute, it will enhance the strength of the tool as well as the material removal. That will be highly significant when you are using for more number of flutes that is provided in this mills. Either it is a nose mill or end mill, whatever the thing. So if it is having with the multiple number of flutes, we can able to increase the tool life surface, and we can able to avoid this vibration of the tools, and we can get a better surface finish in the work part also. Another is a twist drill. Uh, Twist drill. It will have this two flutes on with the for the material removal, and it is for drilling the parts like either for cutting tool or shank body or the cutting edge. Okay, so based on this, the normal generally what we are doing in our conventional machining. So like that we can use this CNC 5-axis machine also. Another next is a circle segmented cutter. So this is like a conical flute-like structure. So this is also specially designed for this 5-axis machine for the contour profiles and for wider cutting contacts. Okay, so because the diameter is goes on increasing, it is a conical in nature. So as in the removal, it has been increasing to the depth of the part. So by we that we can able to increase the contour of the profile. Generally, these type of profiles we can create in this circle segment, that is taper, lens, oval, or barrel type shapes. So that we can able to accomplish in this circle segment cutters. And so this also will yield this good quality of the surface finish at the faster rate with the fewer tool changing, and it will improve the productivity of the cutting process. And these are different variation of different tools which we are commonly using in the CNC machine, this 5-axis machine. Another type, it is a barrel cutters. So it is for having this shape of curved and sloped surface. For that we will use this barrel cutters. So here you can see the shape of the tip of the tool. It is a conical one. Another is a steep conical round surface is there. Okay. So this for this curved surface of this vertical axis. And that how you can able to get this curved surface. For that we are using this barrel cutter machines. And these are a type of some common inserts. So this similar to our turning tools in the vertical tools which we are discussed for end mills. Also we can use this type of insert tools also we can use. So based on the different structure nomenclature, we have this square type, triangle, triagon types are there. So this type of replaceable or indexable inserts can also be used for that different types of end mills we can use it. And coming for this automatic workpiece changer or automatic pallet changer. So we want to have this machine, okay, for a continuous processing time. Even in the machines, we have to run this automatic machine for 24 hours with a zero lead times. So in that, continuously the part has to be fed to a machining center, so that machining also accomplished in the continuous way. So for that only we are accomplishing this automatic workpiece or pallet changes. So it is vastly whenever a new part is coming or any simplified profile is there, so different arrangement setup is there. By that we can able to accomplish this type of automatic palette changer. And also it will minimize this manual intervention and human errors, so that all it can be accomplished by this aid of medium and low volume as well as the high mix production we can use it. And this process will able to our return of investment on the machines we can able to betterly achieve by using this type of additional systems. So this automatic pallet changer, even it is in a 5 axis, either horizontal axis or vertical axis, we can able to install effectively. We can collect not only the parts, even the free falling of this chip also we can able to easily evacuated by this pallet changes. So there are different ways how we can use this pallet changes. Either it can be used for transporting the raw material to load your workstation, or for collecting the finished product. So both the process can be accomplished by this pallet changer. So which will reduce your down time of this part loading and unloading. So here we have this three different methods. One is a manual palleting method, where the human intervention will be there. So he will hold in that earlier said this work holding device, that fixtures, zero clamps and all. He will be holding it and he will be changing the situation of the pallets. Okay, so another is an automated system. So without the human intervention, automatically the system, based on the machining time, automatically the system reads the sensor and it will able to accommodate the different workstations. Another is a robotic system. This robot pallet system generally used for this flexible manufacturing cell or flexible manufacturing system, where two or more machines are incurred in a production system. So for material handling, like material handling here also for loading the work pieces, we will use this robotic pallet systems. So this is a type of manual pallet system. So here it is a multiple pallet system only, but here you can able to see the different fixtures of locating pins, where manually he will fix the part in this system, and this can be in corporate, it will be fixed in a rotary table, and the process will be accomplished. Next, for the automation, so we have this multiple pallet changes will be there. This is a simple dual pallet. You can see one pallet on the either opposite sides. That means one is in the loading for the machining. So you can see the spindle side here. So it is this pallet, it is for machining, and this another pallet, it is for holding the another part. Okay, so it will have this swell movement. So after the completion, so by the rotation of 180-degree, it will come to this position, and you can accomplish this part whichever it is uh, to be uh, to be machined. Okay, so this will be eliminate our setting up times. And next is a 6-station pallet pool. So here again you can see it. So around the periphery there will be a 6 number of stations, and even in the individual station they may have that pallet to come and place in the rear end of the machining part. So the right hand side you can able to see that two pallet arrangement So one that is the spindle side. It is for the where the machining actual machining is taking place. The other part is the loading. Okay. So here either individual transport system can be made or a centralized transport can also be made so that it can pick in this six different pallets. So either the entire pallet itself it will be come into the system, and by this revolving arms will be there. So based on that we can able to produce our work part components. So another is multi pallet changes. So there it is limited to some specific numbers, 2 or 6. So here it is we can go for maximum 19 round of pallets. You can see here, which is accomplished in the machine station itself, where it will be in the continuous movement. Okay, so wherever the different components it will be placed, and here this again this pallet either because of hydraulic or magnetic or pneumatic it will be holding the system. So it defines by the manufacturer how to hold the work part over this pallets. Okay, so here without the errors, the repeatability. See here you can see 0.05, 0025 repeatability. That much accuracy is there. That workpiece will be loaded in a pallet with exactly in that position. Another type of this pallet is pallet charts, pallet carts. So here it is like a trolley. Either the manual he can pull out this pallet to the workstation, or even this trolley type can be with AGVs or some control elements so that it can reach the position of that one a particular workstation. So like this type of arrangement we call it as the carts one. So it will have both the uh, forth and back travel will be there, to and fro motions will be there. So based on the programming also we can able to bring out our pallet at a particular station and we can accomplish the machining part. And this how this one part of the pallet will be changed to the other part. There will be a two mechanisms will be there. One is a shuttle mechanism, so that we call it as a shuttle type pallet changer. Another is a swing type pallet changer. This shuttle type will be like it will be push off systems. So one it is coming to that particular station, one which is already in that station, it will push downs, then the top portion will come to the arrangement for the measuring condition. So like that of arrangement we call it as a shuttle arrangement. And the swing type is it will be in the continuous rotation, either in 120 or 360 degrees. There will be a rotary table motion will be there. So it will come and engage in that particular workstation. It will come and the pallets will able to fix the work component to the to the tool post. So these two types we can able to accomplish our palleting system, automatic palleting system. Next come for this automatic tool changers. So automatic tool changer, it is we have a different number of tools that will be engaged in the workstation, that is in the CNC machine. So by calling the tools, either in by programming mode, we can call the tool. Each tool will be accomplished in a particular station. So the manufacturer will describe which tool station, what type of tool it will be there. So every tool monitoring data will be there in this CNC machines when we are going for high level of production. So the data will be available there. So which workstation, which tool station, what type of tool is there? Either it is an offset tool, either it is a tool length compensation or tool radius compensation. So what type of everything data will be there. So by calling this tool numbers, we can take the tool from this automatic tool changer, and we can accomplish this tool. And even the tool holder that will accomplish that automatic holding of the tool in that particular spindles. We don't want any human intervention for removing or for fixing the tools. Okay, so that is an advantage of this ATC. So generally, minimum station 30 to 40 stations we can go for this this 5-axis machine. So mostly most ATCs it will become around 120 stations is also there. Okay, Okay, and also here we can able to use different tools, as well as we can use the sister tools. Okay, that is repetition of the tool, which have that same profile. So one part of the tool, if even it is going for some regrinding operation. Okay, so the tool, we don't want to wait for that tool has to come. So the second the tool, that sister tool will do that particular operation. So like that, without interference of the production time, we can accomplish the continuous machining process or production process. We can accomplish it. And these are different types of ATCs, where that is tool magazines, where you can able to accommodate here. So this is a disc type and drum type tools. So this is for the vertical spindling. It is a simple arrangement. So there will be a one adapter or holder will be there, standard holder will be there. So in that you can able to fix the different tools. And here in this picture also you can see the grippers. So this is sort of simple disc type arms. So here, this generally it will come with side of the axis, spindle axis of the tool. Here, either from this main tool magazine, how we will bring it, either by a tool arm will be there. There will be a tool arm will be there. So that based on the rotation of the arm, it will pick and place, and it will hold that particular either in the tool magazine or in the machines it will can hold it. Here this type of disc type, we don't want any tool change arm, it is not required. So directly it will goes near the spindle head, and the gripper itself will locate that tool in that particular tool head, spindle head. It will hold the tool. Okay, and also it will dislocate the tool from the spindle head. From the machine also it will that is it will reload that tool also. Okay, so this is one type of arrangement. Another type is a chain type arrangement. So this chain type, based on the different arrangement of chains, either the square pattern or even that different type of alignments will increase the number of tool holding you can able to arrange it. So here there will be a one master gear train will be there, so others will be the follower. So based on the rotation we can bring the particular tool to that particular position. And these chain type, generally we will use this tool changing arm will be there. So that tool change arming will come and pick the tool from this tool magazine, and it will based on the degrees of freedom what we are doing, either 90-degree or 180-degree of rotation, it will hold to the, it will reach to that spindle position. So here the first picture you see, there is a vertical spindle machine is there, and the bottom there is a one plate like structure is there. That is a tool change arm. That is double end tool change arm will be there. So this change arm, it will come to this spindle post. It will remove the tool part here. Okay, and it will rotate to a 90-degree. In the at the same time, it will change the tool take from the spindle, as well as it will take the tool from the magazine also. Okay, so but 180-degree rotation, the other end it will comes to the spindle. So it will hold that tool. The other hand, which already the workpiece that is tool is there, so that will fixed in the magazines. So by that we can able to bring out this automatic tool changes. And this is a pallet type. So when you are going for larger productions, okay, so there is a robot arm which will do the pick and place operation for loading and unloading the tool part. So this also you can able to see how many different number of tools on the matrix. So that arm will come and from the gripper it will collect that tools. So this is a ATC arm tool. So here it is that is semi-arc gripper is there, or full arc gripper is there, and here again you will have both the side grippers are there, and the bottom it is a single side gripper is there. So here this top pictures, it will bring the tool from the magazine as well as the from the spindle. So at a time it will do it, and for 180-degree of rotation we can able to revise our toolings. Okay. And this off and the full gripper, it is based on the gripping force and the type of tool, how the manufacturer is using. So based on that we can use this arm tool, and this it is a single handed. Okay, so here once it has to pick from the spindle, it has to load in the chain, and then from the magazine it has to pick, then it has to go for the spindle to locate. So the number of degrees of freedom, that is rotation, it will be more for this single hand. Okay, so that means timing will be more for changing your tools. And these are tool holders. Okay, how the tool is holded in some fixtures, then only we can able to bring the entire fixture to be in the ATCs. Okay, so there are two types of holders out there. One is a VDI model, another is a BMT model. Uh, this other suitable also we can use this BT holders, that is body taper, and this hollow shank taper tool is there. So in that only we are holding this tools, whatever the tools we are using it. Generally the milling tools, milling and drilling related tools, they are we are holding this in this type of BT and HSK tools. So there are these standard tools where it will that is standard adapters or tool holders. It will be in that prescribed form only. There will be a standard dimensions, diameter that to hold the working tool, and as well as to hold in the spindle head. So it will have some standard dimension only. So based on that only, we will engage our tool in that particular holders. So this we have this tool holders both for this direct head as well as this milling head also. In a general for this VDI model, it is used for this direct head. Okay, you can see the picture where this direct head itself will come with some slot of holes. Okay, so in that we will fix that VDI model. VDI is the Varin literature Ingurin model. So it is using this Allen wrench keys. So we will fix that holder here. So generally it is used for this direct mechanism, that is turning centers, we will use it. And this BMT model, it is also a similar type for holding in that direct head. So it has its own advantage and limitation of holding here, and it depends upon the how it has been equipped with that mechanisms. So based on that mechanism, we will hold this different types of tools. And this is our standard tool holders. Okay, so here you can see this BT taper. So the first one is drill bit adapters, so for holding this drilling tools, and the second one is a standard this BT type or HSK types are there. So here we can use simple taper standards, or we can use the collet chucks for holding our tools. Generally, this will come with the pull stud. So the top of one picture, you can able to see a pull stud. So that pull stud, based on this roller mechanisms, either a ball and that is ball mechanisms or like a collet mechanisms, we can able to insert this part in the spindle head. Okay, so mostly for engaging and disengaging, the entire part will not damage even for after a long time. Only the pull stud it will wear. Mostly wear will be taking place in the pull stud, and pull stud is very small type. It is like a screw type. Okay, so we can just eliminate. We can able to rechange that pull stud. So we can economically use this type of adapters for this our CNC mechanisms. And this you can see that a different arbor for this for boring operations we can go it, and this is a saw blade with the adapters. So different tools we can able to engage. Only the adapter specification will vary, and even the adapter failure will not mostly takes place, because most of this tooling we are using this pull stud mechanisms. So it will helps to hold that part in firmly in that spindle locations. So these are different types of spindles. You can see it, spindle BT tapers. And generally, so these are different classification of this adapters. One, we have this body taper alignment, and DIN standard is there, CAT standard is there, HSK standard is there, PSE and state standard are there. See this first three categories. Okay, this taper, this generally it will be specified with some numbers. Okay, some BT30, BT40 like that. We used to specify that. So that 30-40 remains for the taper of this holders. So the longer the range, the longer the taper will be there. Okay. And here this flange surface, the holding will be different. And which type of tapers or adapters we are using, that particular adapters can be used only for that particular machines. We cannot able to change the adapter system. When we are using in the BT standard, we cannot able to come and fix that CAT V in the BT. Or when we are using the CAT system, we cannot able to replace it with the BT standard or this hollow shank. See the difference between this BT and the hollow shank is, so BT will this will be your external surface. This will insert inside the spindle surface. Okay, wherein this is the spindle will come inside this shank surface. Okay, this HSK it will be the external part. This is an hollow configuration where the spindle alignment it will be come inside that. This all will improve the purpose of gripping when compared to this hollow shank. It will have more gripper purpose. And here you can see that arrangement of this different tools. So this is a milling chuck. How your milling tool has been held in this part. Okay, the collet type chuck is there. So here you can able to see the collet arrangement. Collet will come, ER collets will be there. So based on the different size, we can able to hold this BT tools. And the other side, there will be a screw for holding that pull stud. Okay, so this end it is for engaging in the spindle sections. And this is an hydraulic chuck. So here there will be an hydraulic chamber which will be the integral part within that system itself. So it is used for this clamping grooves, and also it will enhance your supporting when compared to this convention. So general chucks, it will have more efficient in the terms of gripping. And this is another spin jet where it is a coolant circulated adopted type will be there. So along the during a machining process, there will be a slots. There will be a inbuilt coolant supply will be there. So along with that, along with the coolant supply, you can able to run the tool process. So the tool the coolant not only reduces the interface temperature, but also the chipping away of the part during the machining. That will also be pressurized out on that surface. Okay, so this all for increasing the productivity and the surface finish of the components. So this you can see this coolant drive HSM tool, that is high speed machine tool. So there is a spindle here, and that is spindle driven the coolant flow. This spin jet, you can able to see the picture. So there will be a locking mechanism where you can able to load and unload your tools. Okay, cutting tool and coolant jaws will be there. So how you can use that pressurized coolant supply. So this is one type of spin jet tool. We call this as a spin jet tools. And these are this different types of holders. You can see holder for face milling holders, drill chucks. So this BT stands for body taper, and 40 it is the taper. Okay, the taper size is same. Okay, and this Weldon holder, it is for this straight components. For that we will use this Weldon holders. So this is a collet holder, ER collet. So you can see the size of the collet. And the top surface, how much smaller size collet opening is there. So based on that size of the collet, we can select this collet opening is there. So based on the size of the tool, we can select this collet, ER collet. This is an HSK tool. So HSK, it is a cylindrical. It is an outer periphery that will engage the spindle portion. Okay, so this is a HSK is A63 for face milling holder, and this collet type holders, and this is for empty adapters and weld-on holders. So for holding the drilling chucks. So we have this different types of HSK tool holders. So this is another type of this hydraulic or string fit. So generally it is used for machining this milling and drilling related operation, reaming operation and all. So the difference is the holder, it will be slightly smaller than the shank type. In the shank side, that is where you are holding your tool and the spindle. It will be very smaller when compared to your tool side. Uh, this will have this heavier gripper because of this slim wall holder when compared to this other adopters. Okay, so it will have that gripping force will be more, and the tolerance for this cutting shank it will be more when compared to the other things. And with this I will conclude this 5-axis NC machines. So by using this proper tooling, what we are achieving by this NC machine is definitely we are going to increase our production speed and productivity time. We can able to reduce the lead time. So the capacity expansion capacity of the production, that is manufacturer, they can increase their production capacity, they can increase, we can able to improve the accuracy and quality of the machining process, and again the complex geometries based on that different rotary heads or whatever the positioning system or this adapters we are using it, so that we can able to achieve in this tooling system. And a single system which we cannot able to accomplish this different contouring, there will be the changeover of one machine to the other machine, or we have to go for changing of the fixtures, table arrangement setups, we are going to change it, so that it can be replaced by this 5-axis CNC machine. And error can also be eliminated by different setting of the parameters, and longer cutting span by using of this automatic tool selection and this ATC principles. So that will be a long run production will be there. Okay. And so this you can finally achieve by this 5-axis CNC machine. So always the quality with the proper fixture and tooling, we can able to enhance the production and the machining part of the CNCs. So with this, I will conclude my presentation. I once again thank Dr. Dinesh Kumar for giving me the opportunity. If any queries from the participant, you can ask me. Any queries from the participant?
Okay.
Thank you so much, ma'am. Thanks for such a wonderful session.
So thank you for the opportunity.
Ma'am, I need
Thank you, ma'am. Thank you for
to.
joining us and enlightening us. I think someone is having some doubt. Yeah.
Yes, you
Ma'am, I
please.
need. Ma'am, I need today's PDF file.
You need this PDF
Yeah, ma'am.
presentation. Okay, I will share
Yeah,
it.
ma'am.
Okay. So shall we close it?
Yes, ma'am. We'll close it right now, guys. Now today we have one more session rescheduled. Like whatever session will be conducted tomorrow, it has been rescheduled to today 2. So 2 to 3, you will have one more lecture followed by the practical session.